Introduction: The myth of the 10x genius. You look at the world of software development, at the apps on your phone and the websites you use every day, and you see a world of pure, unadulterated magic. You imagine a 10x developer, a hoodie-clad genius who can effortlessly type thousands of lines of cryptic, flawless code, fueled by an endless supply of energy drinks. You've been told a story that to be a real programmer, you need to be a math prodigy, to have started coding at the age of 12, and to possess a rare, innate hacker mindset. You look at a block of code, and it looks like an alien language. You believe that software development is an impenetrable fortress, and you simply don't have the right kind of brain to get in. This is the single most powerful and gatekeeping myth in the entire tech industry, and it is completely false. Modern software development is not magic. It is engineering. It is not about being a lone genius. It is about being a logical, persistent, and systematic problem solver. Writing code is not the primary skill. The primary skill is the ability to take a large, complex problem, break it down into a series of small, simple, logical steps, and then translate those steps into a language the computer can understand. It is the work of an architect. Welcome to From Zero to Coder. This is not a dense, 1,000-page computer science textbook. This is a practical, step-by-step roadmap designed for one purpose: to take you from a complete beginner with zero experience to a hireable, job-ready, full-stack developer. We will treat your career transition not as an academic exercise, but as an engineering project. First, we will demolish the myth of the 10x genius and install the powerful digital problem solver mindset. We will give you a jargon-free blueprint of what a modern web application actually is. Next, we will give you a focused, tactical curriculum for mastering the most in-demand technologies for a beginner. The front-end technologies of HTML, CSS, and React, and the powerful, beginner-friendly back-end language Python. Most importantly, we will guide you through the process of building a single, comprehensive, full-stack portfolio project that will serve as the undeniable proof of your new skills. Finally, we will show you how to leverage that project to build a killer resume, ace the terrifying technical interview, and land your first high-paying job in the tech industry. It's time to stop letting the "I'm not a math person" myth hold you back. Your logical mind and your ability to persevere are your greatest assets. The system is learnable. The path begins now. Part 1. The Foundation. The Architecture of a Modern Developer. Case File 01. The Architect's Mindset. You are not a coder. You are a digital problem solver. Before you write your first line of code, we must perform a critical recalibration of your core identity. The number one reason that aspiring developers quit is that they are operating with the wrong objective. They are trying to be a coder. A coder is a technician. They're obsessed with the language, the syntax, the esoteric details of the programming language. They believe their value is in their ability to write clever, complex, and elegant code. Their primary relationship is with the computer. You are not here to be a coder. You are here to be a digital problem solver. This is a non-negotiable and profoundly important distinction. The primary job of a digital problem solver is not to write code. The primary job is to understand a human problem and then to architect a logical, systematic solution to that problem. The code is the final and often the easiest step of that process. It is the tool, not the work itself. Your primary relationship is with the user and their problem. This should be a source of immense liberation. It means your success as a developer is not dependent on your ability to memorize every obscure function in a programming language. Your success is dependent on your ability to think with ruthless logic, to deconstruct large problems into small, manageable steps, and to persist through the inevitable frustration of debugging. This is the work of an architect, not a magician. You are an architect of logic. You are using the language of code as a building material to construct a machine that solves a real-world problem. When you adopt the digital problem solver mindset, you stop asking the questions of a technician and start asking the questions of an architect. The coder asks, what is the most clever way to write this function? The problem solver asks, what is the simplest, clearest, and most readable way to write this function so that another human can understand it a year from now. The coder spends 80% of their time writing code. The problem solver spends 80% of their time thinking, planning, and drawing diagrams on a whiteboard, and only 20% of their time actually translating that well-thought-out plan into code. Your value is not in your typing speed. It is in the clarity of your thought. Case file 02. Deconstructing the stack. A jargon-free blueprint of front-end, back-end, and databases. A modern web application is like a restaurant. When you, the customer, walk in, you experience the front end, the decor, the menu, the table settings, the friendly waiter. Behind the swinging doors, hidden from view, is the back end, the kitchen, the chefs, the complex systems of inventory and recipes that actually produce the food. The architect understands that any web application is built on these fundamental, interconnected layers. A full-stack developer, the goal of this roadmap, is an engineer who has a competent knowledge of both. Layer 1, the front end. This is the client side. The analogy is the dining room of the restaurant. The front end is everything the user sees and interacts with in their web browser. Its primary job is to create a clear and intuitive user interface. The code for the front end is downloaded from the server and runs on the user's own computer. It is built with 3 core technologies: HTML, which is the skeleton of the web page, CSS, which is the visual design, and JavaScript, which is the interactivity. Layer 2, the backend. This is the server side. The analogy is the kitchen of the restaurant. The backend is the hidden brain of your application. It runs on the company's computers. Its job is to handle the core logic, process data, and communicate with the database. When you click a button on the front end, it sends a request to the backend server. The server does the thinking and sends a response back. The backend can be built with many languages. We will use Python. Layer 3, the database. The analogy is the pantry in the kitchen. The database is where your application's data is permanently stored. It is the organized, long-term memory of your system. This is where you store user accounts and product information. The front end never talks directly to the database. The front end asks the back end, and the back end is the only thing with the keys to the pantry. We will use a SQL database. This 3-layer architecture, front end, back end, and database, is the universal blueprint for almost every web application. Case file 03. The hireable skill set. The core technologies of a job-ready Python developer. The world of software development is a chaotic ocean of technologies, frameworks, and programming languages. The novice developer often makes a critical mistake. They engage in shiny object syndrome. They try to learn a little bit of 10 different languages without ever achieving a deep, hireable level of skill in any of them. The architect does not try to learn everything. They make a strategic choice to master a small, curated, and highly in-demand tech stack. A tech stack is a specific combination of technologies that work together to build a full-stack application. This roadmap is architected to make you an expert in one of the most powerful, versatile, and beginner-friendly tech stacks in the modern world. This is the zero-to-ready tech stack. First, the backend language is Python. We chose it because it is the perfect first language. Its syntax is famously clean, simple, and close to plain English, which makes it much easier to learn. Python is also incredibly versatile. It is the dominant language in the booming fields of data science, machine learning, and AI. Mastering Python opens up a massive number of career paths. For our backend, we will use Flask, a minimalist, beginner-friendly framework that is perfect for building APIs. Second, the database is PostgreSQL with SQL. PostgreSQL is a powerful, open source, and highly respected relational database. Crucially, by learning it, you will be mastering the universal language of SQL, which is a non-negotiable skill for any backend developer. Third, the front-end framework is React. React, created by Facebook/Meta, is the most popular and in-demand front-end library in the world. It is built on the powerful idea of creating small, reusable components that can be assembled to build complex user interfaces. A developer who is proficient in React is in extremely high demand. So, our full hireable tech stack is a front end of HTML, CSS, JavaScript, and React, a back end of Python and Flask, and a PostgreSQL database. By focusing all of your energy on mastering this one single high-demand tech stack, you're maximizing your employability. Case file 04. The Developer's Command Center. Mastering VS Code, Git, and the command line. Before you can start building, you must first set up your professional workshop. A professional developer operates from a sophisticated command center, a specific set of tools that allows them to write, manage, and deploy their code with speed, efficiency, and safety. For the beginner, this can be the most intimidating part of the journey. The architect understands that these three core tools are the non-negotiable pillars of a professional development workflow. This is the Command Center blueprint. First is your code editor, Visual Studio Code, or VS Code. It is free and developed by Microsoft. VS Code is the undisputed, industry-standard code editor for modern web development. It is not just a text editor. It is a powerful, intelligent workshop. Its syntax highlighting automatically color codes your code, making it easier to read. Its IntelliSense intelligently auto-completes your code as you type. And its massive library of free extensions can add new features for any language. Second is your version control system, Git and GitHub. Both are free. Git is a piece of software that acts as a save button on steroids for your code. Every time you make a significant change, you commit that change to Git. This creates a permanent chronological history of every change you have ever made. If you introduce a bug, you can instantly rewind to a previous working version. GitHub is a website that allows you to store a remote, cloud-based copy of your Git project. Your GitHub profile is your new technical resume. Third is your interface, the command line. This is the terminal on Mac or Git Bash on Windows. The command line is a text-based interface for interacting with your computer. It is a far more powerful and faster way to perform many development tasks. You do not need to learn hundreds of commands. For now, you will focus on the core 4 Git commands: git add, git commit, git push, and git pull. Using the command line is a fundamental signal of professional competence. Part 2. The front-end protocol, building what the user sees. Case file 05. The HTML and CSS foundation, the unbreakable laws of web structure and style. We begin our construction with the most fundamental and timeless layer of the entire web, HTML and CSS. Everything you see in your web browser is built on this foundational duo. The amateur developer often dismisses HTML and CSS as easy or not real programming. This is a critical error. A weak foundation in HTML and CSS will lead to a career of building messy and fragile websites. First, HTML, or hypertext markup language, is the skeleton. Its one and only job is to provide the structure and the meaning of the content on a web page. It is not responsible for how the page looks. HTML works using tags. You wrap your content in tags to tell the browser what that content represents, like an H1 tag for a main heading or a P tag for a paragraph. You must use the right tag for the right job. This is called semantic HTML. Use an NAV tag for your navigation bar, a main tag for your main content, and a footer tag for your footer. Second, CSS, or cascading style sheets, is the skin. Its one job is to provide the visual style of the web page. It is the interior designer that takes the raw skeleton of the HTML and makes it beautiful. It controls the colors, fonts, and layout. CSS works by selecting an HTML element and then applying a set of style rules to it. Your HTML file should contain only the structure, and your CSS styles should live in a separate external style sheet. This separation of concerns is a core architectural principle. The most important concept to understand in CSS is the box model. Every single element on your web page is a rectangular box. This box has 4 layers you can control: the content, the padding, which is the space inside the box, the border, which is the line around the box, and the margin, which is the space outside the box. Mastering the box model is the key to understanding layout and spacing in CSS. Case file 06, the JavaScript engine, a practical guide to making your websites interactive. You have built a beautiful, well-structured web page with HTML and CSS. It is a perfect static sculpture. But a modern web application is not a sculpture. It is a machine. It must respond to the user. When a user clicks a button, something must happen. The language that powers this interactivity is JavaScript. JavaScript is the third and final pillar of the front-end trinity. If HTML is the skeleton and CSS is the skin, then JavaScript is the nervous system and the muscles. It is a full-fledged programming language that runs directly in the user's web browser. Mastering the fundamentals of JavaScript is the key to creating modern and engaging user experiences. The core function of front-end JavaScript is DOM manipulation. The DOM, or Document Object Model, is a technical term for the live, interactive version of your HTML that exists in the browser. JavaScript has the superpower to manipulate this living structure. It can find any element, change its content or style, and listen for user events like clicks. Almost everything you will do with front-end JavaScript follows a simple, three-step protocol. Step 1. The selection. You must first select the HTML element that you want to interact with. You will use the document.querySelector method. Step 2. The event listener. You will now tell your selected element to listen for a specific user action. You will use the .addEventListener method. You will tell it what event to listen for, like a click, and what callback function to run when that event happens. Step 3. The action. This is the code that runs inside your callback function. This is where you manipulate the DOM. For example, when a button is clicked, you can select a heading on the page and change its text content. Your next hands-on project will be to add a simple dark mode toggle button to the static portfolio website you built. You will use this three-step JavaScript protocol to select the toggle button, listen for a click, and write a function that adds a dark mode CSS class to the body of your page, instantly changing its style. Case file 07. The React Framework, a system for building modern, component-based user interfaces. You have now mastered the vanilla web development trinity: HTML, CSS, and JavaScript. You have the skills to build any simple, interactive website. But as web applications become more complex, think of a site like Facebook or Netflix. Managing all of that code can become a chaotic, tangled mess. This is the problem that front-end frameworks were invented to solve. A framework is a pre-built architectural system, a set of rules and tools that helps you build a large application in a more organized, efficient, and scalable way. The most popular and in-demand front-end framework in the world is React. The amateur developer sees React as just another complicated technology. The architect sees it as a more powerful and systematic way of thinking about building user interfaces. The single most important idea in React is the component. A component is a small, self-contained, and reusable piece of your user interface. Think of it like a custom Lego brick. Instead of writing one giant HTML file, you will break your user interface down into its smallest logical parts. You might have a button component, a search bar component, and a user profile card component. You can then assemble these smaller components to build larger ones, like a navigation bar. A React component is typically a simple JavaScript function that returns a block of HTML-like code called JSX. Components are not just static blocks of HTML. They are dynamic. They can manage their own internal data, which is called state, and they can communicate with each other using props, which are properties that a parent component passes down to a child component. This allows you to make your components reusable and customizable. This component-based architecture is a revolutionary shift. It forces you to think like a systems architect. It makes your code cleaner, more organized, and infinitely easier to debug and scale. Your next major project will be to rebuild your portfolio website using React, deconstructing your original HTML into a series of small, reusable components. Part 3. The Backend Protocol, Engineering the Brains. Case file 08. Python Fundamentals, from Hello World to your first function. You have mastered the art of building the dining room. the beautiful and interactive front end. It is now time to go behind the swinging doors and architect the kitchen, the powerful, hidden back end that will be the true brain of your application. The language we will use is Python. Python is a general-purpose programming language. Its most celebrated feature, especially for beginners, is its simplicity and readability. Python code is designed to look a lot like plain English, which makes it one of the easiest and most intuitive programming languages to learn. We will focus on the core 4 Python concepts. 1. Variables and data types. A variable is a container for storing a piece of data. You create a variable by giving it a name and assigning it a value. Common data types are strings for text, integers for whole numbers, and booleans for true or false. 2. Lists and dictionaries. These are the two primary ways to store collections of data. A list is a simple, ordered collection of items. A dictionary is a collection of key-value pairs used to store more complex, related data. 3. Conditional logic. This is how you make your program make decisions, using if and else statements. The if statement checks if a condition is true and runs a block of code. The else statement provides an alternative block of code to run if the condition is false. 4. Functions. A function is a reusable, named block of code that performs a specific task. This is the single most important organizational tool in all of programming. Instead of writing the same code over and over again, you write it once inside a function and then call that function whenever you need it. Your first hands-on mission for the backend is to install Python and practice these core 4 concepts in VS Code. These are the fundamental Lego bricks of the Python language. With these in hand, you are ready to start building your first real backend application. Case File 09, the Flask Blueprint, a minimalist guide to building your first web API. You have the fundamental building blocks of the Python language. Now, it is time to use those blocks to build the kitchen of your web application. The primary job of your backend is to be an API or application programming interface. An API is simply a set of defined endpoints, which are URLs that your front end can send requests to in order to get or save data. When your React front end needs a list of users, it sends a request to an endpoint like www.urapi.com/users. The backend then gets the data from the database and sends it back. Building a web server from scratch is complex. This is why we use a web framework. A framework is a collection of pre-written code that handles the difficult plumbing of a web server. The framework we will use is Flask. Flask is known as a micro-framework. It is deliberately small, simple, and unopinionated. It gives you the bare essentials you need to get a web server running in just a few lines of code. This is the Hello World API blueprint. Step 1. The import and initialization. First, install Flask from the command line. Then, in your Python file, you will import the Flask class and create an instance of your web application. Step 2. Defining a route. A route or endpoint is the specific URL that a user will visit. You define a route using a special piece of Python syntax called a decorator. The add route. Decorator tells Flask that the function immediately below it is the code that should run when someone visits that URL. Step 3. Running the server. You will run your Python file from the command line. You will see a message that a server is now running on your computer. If you open that address in your browser, you will see your result. To make this a real API, we needed to send back data in a structured format called JSON. Flask has a built-in helper function called demystifies to do this. You can create a new route like /API/books that returns a list of books perfectly formatted as JSON, ready to be consumed by your React front end. Case File 10, the database connection. How to talk to a SQL database with Python. Your Flask API is now capable of sending back hard-coded dummy data. To make your application a real, dynamic system, your backend must be able to communicate with a database. This is the pantry where your application will permanently store and retrieve its valuable information. Directly writing raw SQL commands in your Python code can be tedious and error-prone. A more professional, efficient, and safer way to interact with a database is to use a tool called an ORM, or Object Relational Mapper. An ORM is a powerful library that acts as a translator. It allows you to interact with your database using simple Python code, and it automatically translates your commands into the complex SQL that the database understands. The most popular ORM in the Python world is SQL Alchemy. This is the SQL Alchemy blueprint. Step 1. The model. This is the blueprint for your data. Before you can store data, you must first define its structure. In a relational database, data is stored in tables. A model is a Python class that you will write that serves as the blueprint for a table. For example, you can define a simple book model, telling SQL Alchemy to create a table called book with 3 columns: ID, title, and author. Step 2. Querying the database. This is how you get the data. You can use your Python book model to perform all the standard database operations without writing a single line of SQL. In a Flask route, a single line of Python book.query.all can get all the books from the database. You then format them to be sent as JSON. Step 3. Creating new data. To add a new book to the database, you simply create a new instance of your book model in Python and then commit to the database. You can create a new API endpoint that accepts POST requests. It will get the new book data from the incoming request, create a new book object, add it to the database session, and commit the change. By using an ORM like SQL Alchemy, you have abstracted away the complexity of the raw database language. This is the core, foundational skill of a back-end developer. Case File 11. The Authentication Mandate. A simple system for user logins and security. Your application can now store and retrieve public data, but almost every real-world application needs a way to manage users. It needs a system for users to sign up, to log in, and to access their own private data. This is the world of authentication and authorization. Authentication is the process of verifying who a user is. Authorization is determining what an authenticated user is allowed to do. This is a critical, high-stakes part of any application. The architect does not try to invent their own security system from scratch. You will use standard, industry-proven libraries to handle this. This is the password hashing and JWT blueprint. Step 1. Storing passwords securely. This is the hashing mandate. The unbreakable law is that you will never, ever store a user's plain text password in your database. This is a company-killing mistake. The solution is password hashing. A hash is a one-way cryptographic function. You take a password, run it through a hashing algorithm, and it produces a long, random-looking string. This is a one-way process. You cannot reverse engineer the hash to get the original password. When a user logs in, you hash the password they just typed and compare that new hash to the hash stored in your database. Step 2. Managing the logged-in state. This is the JWT protocol. The internet is stateless. Once a user logs in, how does your backend remember who they are on their next request? The solution is JSON Web Tokens, or JWT. A JWT is a secure, digital access token. After a user successfully logs in, your backend will generate a JWT and send it to the user's front end. The front end will store this token. For every subsequent request to a protected API endpoint, it will include this JWT in the request headers. Your backend will then check the validity of this token on every request. Your hands-on mission is to create 3 API endpoints. The /register endpoint that hashes the password and saves a new user. A /login endpoint that verifies a password and returns a JWT, and a protected /profile endpoint that requires a valid JWT. Part 4. The Career Engine, from Code to Contract. Case File 12. The Portfolio Project. Architecting a full-stack application from scratch. You have now mastered the fundamental building blocks of the entire web development stack. You understand the front-end architecture, the back-end architecture, and the security protocols for user authentication. You have all the individual Lego bricks. Now, it is time to assemble them into a single, comprehensive, and impressive full-stack portfolio project. This is the culmination of your entire journey. It is the tangible, undeniable proof that you are a true full-stack architect. This is the job-ready full-stack project blueprint. Your mission is to build a simple but complete CRUD application. CRUD stands for create, read, update, delete, the four fundamental operations of any data-driven application. The project idea is a personal project tracker app. It is a simple web application where a user can sign up, log in, and manage a private to-do list of their personal projects. This project is simple enough to be achievable, but complex enough to require all the core components of our tech stack. This is the architectural blueprint. For the backend API, you will build a Flask API with a PostgreSQL database. You will create a user model and a project model in SQL Alchemy. You will implement the full user authentication system with endpoints for register, login, and a protected profile route. You will create the full set of protected CRUD endpoints for the user's projects. This includes getting a user's projects, creating a new project, updating a project, and deleting a project. For the front-end UI, you will build a modern, single-page application using React. You will architect the UI as a series of small, reusable components. You will create separate pages for signing up, logging in, and the main dashboard. Your React components will fetch data from your backend API, sending the JWT to your protected routes. The user will be able to manage their projects without ever having to refresh the page. Your final deliverable will be a live, working version of your web application and a clean, professional GitHub repository. This is your key to the industry. Case File 13. The GitHub profile. How to showcase your code and your thinking process. You have built your masterpiece, a complete, working, full-stack application. The code sits in a folder on your computer. This is a huge personal victory, but for a hiring manager, it is still invisible. Your GitHub profile is the public gallery where you will showcase this masterpiece. A recruiter or a senior engineer will spend less than 30 seconds on your GitHub profile. A messy, disorganized, and poorly documented profile is an immediate red flag. The architect knows that their GitHub profile is a critical piece of their professional brand. This is the professional GitHub blueprint. First, the profile README. GitHub allows you to create a special repository with the same name as your username. The README file in this repository will be displayed as your main profile page. This is your digital business card. It should have a brief intro, a list of your skills, and a link to your portfolio website. Second, the pinned repositories. GitHub allows you to pin up to 6 of your most important repositories to the top of your profile. Your full-stack, personal project tracker application must be your #1 pinned repository. Third, the project README. This is the most important piece of documentation you will write. It is the case study that explains your project to a busy reviewer. It must include the project title and a prominent, clickable link to the live demo. It should have a short description, a clear list of the tech stack you used, and a bulleted list of the key features. It must also have a simple, step-by-step guide on how another developer could get your project running on their own machine. This is a huge sign of a professional. Fourth, the clean commit history. Git tracks every single commit or save that you make. Your commit messages must be clean, professional, and descriptive. A bad commit message is fix stuff. A good commit message is feat, add user registration endpoint, or fix, corrected bug in project deletion logic. A clean commit history shows that you are a disciplined, methodical developer. Case File 14. The technical resume. Translating your project into recruiter-ready language. You are now a proven builder. You have the skills. You have a full-stack project in your GitHub repository. But before you can get to the technical interview, you must first get past the gatekeepers, recruiters, and the automated applicant tracking systems, or ATS. An ATS is a piece of software that scans your resume for specific keywords. A human recruiter will then spend, on average, 6 seconds scanning the resumes that the ATS approves. Your resume is not a detailed biography. It is a high-impact, keyword-optimized advertisement designed to pass this brutal test. This is the ATS-optimized resume blueprint. You'll create a clean, simple, single-page resume. Section 1 is the header. It includes your name, contact info, and, critically, clickable links to your portfolio website, your LinkedIn profile, and your GitHub profile. Section 2 is the professional summary. This is a 2 to 3 sentence, keyword-rich summary of your value proposition. Section 3 is technical skills. This is a dense, scannable, keyword-optimized list and a primary target for the ATS. Break it down into logical categories: languages, frameworks and libraries, databases, and tools and systems. Section 4 is projects. This is the heart of your resume and the proof that backs up your keywords. You will dedicate the most space to your portfolio project. Use action verbs and quantify your results with bullet points. For example, architected and developed a full-stack web application using a React front-end and a Python/Flask backend API, and engineered a secure user authentication system with password hashing and JWT. Section 5 is experience and education. Even if your past experience is not in tech, you will frame your bullet points to highlight transferable, problem-solving skills. For example, instead of serve customers at a coffee shop, say managed multiple concurrent customer requests in a fast-paced environment. This engineered document is designed to be easily parsed by the ATS, scannable by a human, and to immediately direct their attention to your portfolio project. Case File 15, the Whiteboard Gauntlet, a playbook for acing the live coding challenge. You've made it. Your resume and your portfolio have passed the test. You are now in the final and most formidable stage of the hiring process, the live coding challenge or whiteboard interview. You will be in a room with a senior engineer. They will give you a programming problem, and they will watch you solve in real time. This is the single most anxiety-inducing experience for most new developers. The amateur, in a state of panic, makes a fatal mistake. They immediately start trying to write perfect, working code. They go silent. The architect understands that the coding challenge is not a test of your coding ability. It is a test of your problem-solving ability and your communication skills. The interviewer is not looking for the most brilliant solution. They're looking to see how you think. This is the Think Out Loud whiteboard protocol. The meta rule that governs all 4 steps is, you must be talking the entire time. You are narrating your thought process. Step 1, the clarify and deconstruct phase. This is the most important step. Do not start coding. Start questioning. Repeat the problem back in your own words. Then, ask clarifying questions to identify the edge cases. For example, should I consider uppercase and lowercase letters as the same character? What should I do if there's a tie? What about an empty string? This proves you are a careful, methodical architect. Step 2, the pseudocode phase. This is your blueprint. Still without writing real code, sketch out the high-level, step-by-step logical plan for your solution in plain English. First, I'll create a character map to store the count of each character. Then, I'll iterate through the string. The interviewer has already given you a mental pass because they can see that you know how to think. Step 3, the coding phase. Now, you will translate your pseudocode blueprint into actual Python code. As you write, continue to narrate what you are doing. It is perfectly acceptable to have a small syntax error. Step 4, the testing phase. Once your code is written, you will manually test it with a simple example. Okay, let's just quickly run it with an example string, like hello. By following this structured, communicative protocol, you're transforming the coding challenge from a terrifying test into a collaborative design session. Conclusion: you are the architect of the digital world. You began this roadmap with a myth, the myth of the 10x genius, the prodigy who was simply born with a coding brain. You saw a world of cryptic languages and complex algorithms, and you may have believed that you were not qualified to build in it. That myth has now been fully deconstructed and replaced with an engineered reality. You now know that software development is not magic. It is architecture. It is not about innate genius. It is about a learnable, systematic process of problem solving. You are not a coder. You are a digital architect. You have deconstructed the full stack of a modern web application, mastering the fundamental building blocks of the front end, the back end, and the database. You have filled your toolkit with the most valuable and in-demand technologies in the world: Python, Flask, React, and PostgreSQL. Most importantly, you have moved beyond theory. You have the blueprint for building a real-world, full-stack application from a blank page, a project that serves as the undeniable proof of your new skills. You have the system for showcasing that project on your resume, in your GitHub, and you have the protocol for confidently navigating the final, most challenging test, the live coding interview. You do not just have knowledge. You have a complete, end-to-end plan for launching your new, high-income career in tech. The path from here is one of building. It is the work of writing the code, of persisting through the frustrating bugs, and of applying these systems to create real, tangible value. Your logical mind, your patience, and your systematic approach are not just helpful traits. They are your superpowers. You're no longer a passive user of technology. You are an architect of it. You possess the skill to take an abstract human problem and translate it into a working, logical machine. You're an architect of the digital world. Now go build. Did this roadmap help you? Your journey is just beginning, but your feedback is crucial. If this book provided you with real-world value, the single best way to support this mission is to leave an honest review on Amazon. More by Gardinski. Your roadmap continues. Mastering the code is the first step. The next is to deploy it and apply it. Continue building your high-value skill set with these roadmaps. Book recommendations include From Zero to Cloud Certified and From Zero to Leader.